In this video, we will cover 5 questions that cover target 2D. We'll start with question number 16, move on to 17, 18, 19, and finish up with number 20. Back to number 16, this problem is dealing with completing the square, and it asks us to find the value of C. Now, the value of C is the number that we want to add to the left side and to the right side of the equation to help us complete the square. And we get that by taking our B term right here. Remember the standard form of a quadratic equation? Our B term is in front of the x. So right here our B term is going to be 18. That's the number in front of the x. So we take 18 and we're going to divide it by 2, and then that we're going to take and square it. So 18 divided by 2 is 9, and then we want to square 9. That ends up being 81. So that's what we would add into the left side and to the right side. That's what C is going to equal. If we went on to factor this, we'd have an x squared plus 18x plus 81 that we need to factor. Well, that factor would be x plus 9 squared. Well, actually it would be x plus 9 times x plus 9, which we'd write like this, but we didn't have to go that far for number 16. Question number 17 is asking us to figure out our next step. So right in here at this point there is a negative 16 for our B term, right? Remember, our B term is in front of the x. And they took that negative 16 divided by 2 and squared it, which ended up being 64. That's what was added to the left side and to the right side. Now we have a trinomial here, and that's what we want to factor, just like what I did to finish up question number 16. So we need to figure out two numbers that multiply together to get a positive 64 and add together to get a negative 16. And that number is going to be negative 8. So I'm going to write x minus 8 and then another x minus 8. That's going to be the factors of this trinomial. We still have 63 on this right side, and if I have two binomials that are the same, I could write it as the quantity of x minus 8 squared. That will be 63 as well. So that would work for a final answer too. Question 18 is asking us to do it all by ourselves now. So the first thing that we want to do is get our x squared and our x by themselves. I take away 16 from the left side and the right side. That goes away. Now I'm left with this equation, right? And we want to add in a number to this left side here so that we can complete the square. So I'm going to rewrite this. And as you can see, I have a space here to add in a number on the left side, and then to keep everything balanced, I have to add it on my right side as well. So I take my B term, which is negative 10, I divide it by 2, and I need to square it. So negative 10 divided by 2 is 5, and then if I square 5, that's going to be 25. That's the number that I add into the left side and to the right side. Now I can factor this. Two numbers that multiply together to get 25 and add together to get negative 10 is going to be a negative 5. So there are my two factors right here. We have a minus 5 and our minus 5. I combine these terms to give me 9. Now I could write this as the quantity of x minus 5 squared, which equals 9. To undo that, the squaring here, I want to take the square root of the left side, which I have to do to the right side as well. Now I'm just left with an x minus 5 on the left side, right? But this is going to be plus or minus on the right side over here, because whenever you take the square root of a variable that's being squared, you have to consider two different answers. So it's going to be plus and minus. The square root of 9 is 3. So now that I have two different answers, I have a plus 3 and then a minus 3, I'm going to write that like, well, I guess we don't have to. We could keep it all together. I'm going to add 5 to this left side to get rid of that. I'm going to add 5 to this right side. X equals plus or minus a positive, oops, actually that's going to be 3, and then plus 5. Now, like I was saying before, I had a plus or minus 3. So I have to take the positive version of 3. I'm going to do that over here. It's going to be positive 3 minus, whoops, no, it's 5. It's going to be plus 5. And then I also want to do x equals minus 3 plus 5. So if I continue to solve this, that's going to be 8. If I continue to add these like terms, I'm going to have a positive 2. So my answers for x will be 8 and 2. Both of those work. Question number 19 is having us complete the square in an application situation. So I'm going to take my my function here, b of t, and I'm going to rewrite. My first step is going to be to take away this constant number, the 13, so I subtract it from both sides. This is going to cancel out, and I'm left with this equation right here. Now I can complete the square. So I rewrote my equation to make space for when I have to add in my number to be able to complete the square. So my next step is going to be taking my b term, right? That's going to be in front of this term. So that's negative 4. I want to divide it by 2, like always, and then I want to square it. So negative 4 divided by 2 is negative 2, and I square negative 2, that gives me positive 4. So that's what I add to the left and right side of my equation. Now I combine my terms up here and I just rewrote everything. So here's my equation, and I want to factor this trinomial now. So the two numbers that multiply together to get a positive 4 and add together to be a negative 4 is going to be a negative 2. So I'm going to write those as my factors. And when I mean I want to write them as my factors, I put them in the form of a binomial. So I have t minus 2 times t minus 2. I could rewrite that as the quantity of t minus 2. And we're going to be squaring that. And the last thing that I want to do here, because I want to put it in the vertex form, and I'll explain that in a minute, is add 9 to both sides. So I do that, this cancels out, and now I'm left with this equation. And this resembles vertex form, and if you recall, vertex form is written like this, where h comma k is going to be our vertex of the parabola. So we want to call out the vertex here. We're subtracting a positive 2 in this equation down here. So my h is going to be 2 of my vertex, and then my k is always what's being added on the outside of parentheses. So 9 is going to be my k. So that's going to be my vertex. Now back to the problem here. It says we want to look for the minimum. So it looks like that this vertex right here is going to be where the minimum happens. Now the minimum is where our minimum is our y value. So our y value is 9 here. So what does 9 represent? Well, remember that our y is always my function too. So b of t will represent the number of bacteria in millions. So 9 will actually mean 9 million bacteria. But what about the 2? Well, the 2 is where the x is, and in this problem my t took the place of x, and it looks like t represented it says where t is the temperature in Fahrenheit. So our temperature is going to be 2 degrees Fahrenheit. So at 2 degrees Fahrenheit, we're going to have 9 million bacteria. Question number 20 seems to be pretty similar to question number 19, except we need to find the maximum. So let's rewrite this equation and we'll go through all the same steps. Now, like the last problems, the first thing we want to do is take away this 60,000. So I'm going to do that. So that goes away. I'm going to rewrite my equation. So here's what we have now. And something to point out that didn't happen yet is that there's a number in front of my quadratic term here. My w squared has a number in front of it, and we have to take account for that. So we see if we could factor that out of these two terms, kind of treat it like a greatest common factor, and we can. We'll divide out a negative 100 from this term, and we'll also divide out a negative 100 from this term. So let's go ahead and start to do that. I keep everything the same over here, but now I want to divide out a negative 100 from that term and then also this term. So my negative 100 comes out in front, and then I'm going to write all my leftovers over here. So that goes away. I'm just left with a w squared. 1000 divided by the negative 100 is going to be just a negative 10w. And then I'm going to actually keep this right side open here, okay, because I know that I have to add in some numbers so I can complete the square. Something else to notice is that this was plus, but because we were dividing it by a negative, now it becomes negative, so the sign changes. All right. So back to my completing the square process. We want to take this b term right here, right, that negative 10, and we're going to divide it by 2, and then square it just like we've been doing this entire time. So negative 10 divided by 2 is negative 5. We square negative 5, it gives me 25. And now I add that to this right side here. Now I'm going to add it over here to my left, but something would be messed up with that. And here's what the situation is. If I add in 25 to this part right here in parentheses, I'm not just adding in 25. I'm actually multiplying this part in parentheses by a negative 100. So by adding in 25, I'm actually adding in a lot more because I'm multiplying it by a negative 100. Negative 100 times 25 is actually negative 2500. So that's how I'm affecting the right side of my equation. So let's get rid of this 25 here. I actually want to take away negative 2500 from this left side. So be careful of that. That's one of the big differences with this problem compared to the other ones. So now let's go ahead and simplify this left side. So we have that. I'm going to keep my negative 100 in front, and now I want to factor this trinomial, right? So what times what gives me 25 and adds together to be negative 10? That's going to be a minus 5. So I put that number twice there, and I finish up by writing my w. So there's my two factors. I'm going to rewrite this as the quantity of w minus 5 squared. And I'm also going to add I'm going to add in 57,500 to the left side and the right side to get my final vertex form. So here's my final equation. It's in vertex form. So I have r of w equals negative 100 times the quantity of w minus 5 squared. And then we're adding 57,000 up. That's 500. So this is what we have. Now remember, let me recall my vertex form. Here it is right here, and my h is going to be this number right here. So we're subtracting h, so we're subtracting 5. That means that 5 is going to be my h, and then we always add in k, right? We're adding in k on this right side, so k is going to be my y value, so that's going to be 57,500. So there is my vertex, and my vertex represented the location where my maximum was happening. Remember, my maximum is always pertaining to my y value, which was 57,500. So now, what does y represent? Well, if we look at our original function, we have r of w up here, and that matches up with y. So what does r of w represent? It seems like that's going to be their revenue. So that's going to be how much money they take in. So it looks like we are taking in 57, and that ends up being thousands. So 57,500 is going to be the revenue. And then what is my x value here, right? So x value was replaced by w. So I go back to my equation here, and what is w going to represent? So w represents the price of the wig. So it seems like the price of the wig will be $5. So I'll write that down here as well. So my revenue is going to be $57,500, and that's when the price of the wig is $5. And that maximizes the revenue too. So you want to consider the whole context of everything as well. So to recap everything, we had started off with question number 16, moved into 17, number 18, and then 19 as well as 20 were some word problems that we were dealing with. So everything really had to deal with completing the square.